Okay, Assalamualaikum and good morning. Boleh dengar dan boleh nampak screen Can you hear my voice and you see my screen right now?
Boleh, boleh.
Okay.
Can.
So it's already 10:02 a.m. So I think we can just start our class for today. So basically today we will start with a new chapter, which is chapter 2. So chapter 2 is direct current circuits or DC circuits. Okay. So in the previous class, okay, basically you have learned on the introduction to electrical and also electronics engineering. Okay, and one of the subchapters is the differences between direct current and also AC current for DC and AC. Okay, so basically for this chapter, for the analysis part, we will only consider the DC circuit. Okay, since this is a fundamental subject for electrical engineering. Okay. Okay, so these are the learning outcomes for chapter 2. So basically we have 4 learning outcomes, okay, that you need to achieve. So the first one, you need to be able to calculate the power and energy and determine whether the energy is supplied or absorbed by circuit elements. And then able to state and apply Ohm's law. So both of these, learning outcome 1 and learning outcomes number 2, will be covered in this week class, week 2 class. The third one, the recognize series and parallel circuits and calculate the total resistance. And the last one, able to apply the suitable theorem of circuit theory voltage current divider or Kirchhoff's law or mesh and node analysis to solve electrical circuits. So learning outcome number 3 and number 4 will be covered in the following weeks. Okay. So this chapter consists of 15 subchapters. So if you refer to this slide, okay, so you can see that for week 2, which is this week, we will cover from 2.1 until 2.7. And then for next week, we will cover for 2.8. Week 4 will be covered from 2.9 until 2.12. And then week 5, we will cover 2.9 until 2.14. And week 6, we will cover 2.15. Okay, so basically for this whole chapter, we will cover it in 5 weeks. Okay, in total. Okay. Okay, so the first subchapter is the DC sources. So basically, this is just a repetition from the previous lecture. Okay, so what is DC source? So DC is actually direct current. Okay, so when we talk about direct current, is a constant flow of electrical charge with time. So basically, if you have a graph with respect to time like this, okay, graph with respect to time, basically the voltage or the current will be fixed or constant. Okay, so over here the voltage is fixed at 5 volt. Okay, so over here the voltage is fixed at 5 volt. Okay, sorry, 5 volt. Okay, and over here it stated that for ideal voltage source and ideal current source, they supply fixed voltage and also fixed current. Okay, this is ideal voltage source. However, in real application, we cannot get an ideal voltage source or current source. Ideal sources does not exist. Okay, why is it that ideal sources is not exist in real application? Is because, for example, if you have a battery, okay, which stated that it will supply 5 volt, but basically the exact voltage is not 5 volt. It could be 4.9, it could be 4.98 because there's a error. Okay, and this is also because there is an internal resistance inside the source itself. Okay, however, in the analysis, we use the ideal sources in order to simplify the circuit analysis. So basically, for example, in this class, Okay, given a circuit, basically we will give the source 5 volt, okay, 10 volt, okay. We don't give you 4.99 volt, 4.98 volt as the source. Okay, we assume it as an ideal. Okay, so this also already been covered in the previous class. So basically, you know, voltage source or current source, there are two types. The first one is independent voltage source. The second one is the dependent voltage source. Okay, so the independent voltage source is an active element that is independent of other elements. Okay, dependent is that the source is dependent with other elements. So if you look at this figure here, sorry sekejap saya tak boleh nak tulis. Okay. So if you look at in this figure here, so this is the symbol for battery. Okay, so remember battery will always supply a DC voltage. Okay, DC voltage. Okay, this symbol is for, can be used for DC, can also be used for AC. Okay. So if you look at here, both of these voltage source is the independent source. Okay, this is an independent source. This one is also a voltage source, but is a dependent voltage source. Okay, so you can differentiate between the independent source and the dependent source. The first one based on the shape. So this one is round. This is one is like a diamond shape. Okay, so if you have a source like this, you can directly know that this is the dependent source, and because you have a positive negative like this, so this is the voltage source. Okay, so another thing that you can look into if you want to differentiate whether it's an independent source or dependent source is the value itself. So if you look at for the independent source, the value is Vs. The value is V voltage. Okay, so it is independent of the other elements. For this one, even though it's a voltage source, but the value is actually dependent to the I1. I1 is the current. So that's why for the dependent source, this one, we call it as current controlled voltage source. Okay, the voltage source is controlled by the current I1. Okay, so there are two types of dependent voltage source. The first one is voltage controlled voltage source, VCVS, and the second one is current controlled voltage source. Okay, so the VCVS basically the element that is, this is dependent to the voltage, is dependent on the current, okay, I. So the sign of voltage source can be negative. You must take note that for voltage and current, the sign can be negative. So for example, if in a circuit, you're given a source like this, okay, this one, positive, negative, so the value is 12 volt. But sometimes in certain cases, for the analysis, you are required to flip the voltage source, okay, flip the voltage source upside down like this, okay, negative, positive. So if you flip the voltage source like this, you must also change the value from positive to negative. Okay, this one is another example. If you have a in a circuit, you have a voltage source like this, negative, positive, the value is 12 volt, but if you flip the voltage source, okay, you must make sure that you need to also change the magnitude from positive to negative. Okay, so basically this one and this one is the same, this one and this one is the same. Okay. Okay, so this one is the difference between for different dependent source, different dependent voltage source and also current source. So if you look at the first one here, you know that this is the independent. Okay, this is the independent source. This is the dependent source. Okay, this source is a voltage source. Okay, but it is dependent to the Vx. So that's why we call it as voltage controlled voltage source. The voltage source is controlled by another voltage. This one, this is the independent source. This is the dependent current source. So if you have an arrow like this, this is the current source. Okay, but the current source is dependent to the voltage. That's why we call it as voltage controlled current source. This one, this is the dependent current source. It is dependent to the current. So that's why the name is current controlled current source. And the last one, this is the voltage source, dependent voltage source. It is dependent to the current. So the name is current controlled voltage source. Okay. So now let's look at the connection of the DC sources. So basically stated over here, voltage source can be connected in series. Okay, it can be connected in series. So if it's connected in series like this, we look at here, this is in series. So if you have something like this, the voltage source is connected in series. Okay, so if you have a connection of the voltage source like this, you have two voltage source connected in series, you can actually simplify this. Instead of using two voltage source, you can convert it into one voltage source. Okay, so the new voltage source will be the VT, V total. To get the V total, you just add the V1 and also V2. V1 plus V2. So this one is V1, this is V2. Actually, you can just use one voltage source instead, which the value is Vt equals to V1 plus V2. Okay. So you can connect the voltage source in series. However, the voltage source cannot be connected in parallel. Okay, it cannot be connected in parallel, cannot be connected like this. So this is the parallel connection. Okay, V1 and this is V2. Why does the voltage source cannot be connected in parallel is because, for example, if you do a KVL, okay, you haven't learned KVL yet in this chapter. You will learn KVL in the maybe in next week class, but basically what KVL stated that the total voltage in this loop is basically equals to 0. So in this loop is basically 3 minus 2 equals to 0. Okay, so basically you will get 3 is not equals to 2. Okay, so this will result in an inconsistent equation. Okay, the circuit get confused whether the voltage source is actually 3 or 2. So that's why you cannot connect the DC source in parallel to each other. Okay. So that one is for the voltage source. Now we'll go into the current source. The same as voltage source, current source also has independent source and also dependent source. Independent source, independent of other elements. Dependent current source, it is dependent to the other elements in the circuit. So if you look at here, this one, if you have a source with an arrow like this, meaning this is the current source. If it's a round shape, then it's a independent source. If you have a diamond shape, this is a dependent source. Okay, and then you look at the value. This one is dependent to the voltage. So the name is voltage controlled current source. Okay. Same as the voltage source, for the current, you have positive magnitude, you have negative magnitude. Okay, so there are two types of dependent current source. This one already explained before. We have voltage controlled current source, and we also have current controlled current source. Okay, so this one, the one at the bottom here, this one to show you that current source can be positive, it can also be negative, okay, depending on the current flow. So if you have a circuit like this, okay, 2 ampere, the arrow is upwards, okay, but maybe you want to flip the current source, okay, make it downwards like this. You must make sure that to change the voltage, the value also from positive to negative. Okay, see, same for this one. If the existing circuit has a voltage source downwards and the value is 2 ampere, so if you flip it upwards, you must make sure to convert the value from positive to negative. Okay, so in the previous slide, it stated that for voltage source, remember for voltage source, this is current source. For voltage source, remember, you can connect it in series, but you cannot connect it in parallel. Okay, this is different to the current source. Current source, you cannot connect it in series. Okay, if you look at here, the current source is connected in series like this. You have I2 and also I1. Okay, so basically the current flow in a series circuit, basically the current is the same. It should be I2 equals to I1. Okay, it cannot be a different current I2 and I1 flowing in the same series circuit. Okay, so that's why for current source, series connection cannot be used. Okay, however, if is the current source can be in parallel. Okay, so this is a parallel connection. You have I1, you have I2. Okay, two current source. Basically, you can actually convert this into only one current source. Okay, instead of using two, you can use only one current source, but you need to calculate for the I total. This is the I total. This is the I total. So I total is I1 plus I2. Okay. So this one is the same as this one. Okay. So if you have any question, you can just directly ask during the lecture. Next is the Ohm's law. Okay. So in the previous slide, you already learned on the voltage, you already learned on the current. Okay, now we'll look into the resistance, R. So resistance is a characteristic of material to resist the flow of electrical charge or current. Remember, flow of electrical charge is actually the current and it's represented by the symbol R. Okay, to resist the flow of current in a circuit. So the resistance of any material with a uniform cross-sectional area depends on A and its length L. So this is the formula for resistance. Okay, so resistance is equals to rho L divided by A. Rho, this is a symbol for rho. This is the rho. The rho is actually the resistivity. L is the length. A is the area. Okay, so this is the length. This is the cross-sectional area. Okay, and for different material, you have different resistivity value. Okay. So for the resistivity, you can refer to this table. So if you look at here, different material has different resistivity. Okay. So if you look at here, for conductor, so conductor is materials that is very good in conducting electricity. Okay, it can conduct electricity. Insulator is not good in conducting electricity. Between conductor and insulator, we have something that is called the semiconductor. Okay, so conductor we have silver. Conductor we have silver, copper, aluminium, and gold. Okay, so all these materials is very good in conducting electricity. So if you look at here, the conductor has a low resistivity. Okay, so you look at here, silver is 1.64 10 to the power of negative 8, 1.72 10 to the power of negative 8, and so on. But if you look at here, the insulator has a high resistivity. Okay, glass, the resistivity is 10 to the power of 12, Teflon is 3 to the power of 12, paper is 10 to the power of 10. Okay, so basically paper is not good for conducting electricity. Okay, so this is the value. Okay, so if you're given questions to calculate the resistance, then you need to know the resistivity of the material, which is this one. Okay. So this is the Ohm's law. So Ohm's law stated that V is equals to IR. V is the voltage, I is the current, R is the resistance. Okay. Based on this equation, you know that V is directly proportional to current. Voltage is directly proportional to current. So if the current increase, the voltage will increase. If the current decrease, the voltage will decrease. So basically, you have a graph V with respect to I like this. So if the current increase, the voltage will increase. Okay. So over here it stated that good conductor such as copper and aluminium have low resistivity. Insulator such as mica and paper have a high resistivity, which is not good for conducting electricity. Okay. Two extreme positive values of R is R equals to 0 and also R equals to infinite. So these two values of R are related to the basic circuit concept, which is the short circuit and open circuit. So